Every year there are serious accidents involving confined spaces in the workplace. A significant number of these are fatal, and it is not uncommon for accidents to result in multiple fatalities. In order to reduce the number of confined space accidents, we need to have a fundamental understanding of the hazards and risks that are associated with confined spaces in the workplace. The logical starting point is to first understand exactly what is a confined space. A confined space is any enclosed or partly enclosed structure that is large enough for a person to enter, has a limited or restricted means of entry or exit, is not primarily intended or designed for human occupancy, and contains one or more of the following characteristics: a potentially hazardous atmosphere, a potential engulfment hazard, or any other hazard that presents a health or safety risk to anyone entering the space. As you can appreciate from the definition, there are many confined spaces. Here are just a few examples: tanks, vessels, vats, ducts, storage bins, containers, tunnels, wells, pipes, sewers, mills, crushers, boilers, and trenches. It is also important not to confuse the size of a space as being significant to the definition. A confined space is not necessarily small. Now, because there is such a wide variety of confined spaces, it is not possible to have a definitive approach when looking at the safety aspects of working in confined spaces. Almost every confined space is unique, and the problems associated with them vary greatly. Because of the dangers associated with confined spaces, access is controlled by the issuing of work permits. These permits are often referred to as confined space entry permits. This is in itself a little confusing, as these permits go a lot further than simply addressing the safe entry. Typically, a permit will cover at least the following: the name or names of anyone being given access, the location of the confined space, a description of the work to be performed, requirements that are necessary to isolate the confined space, requirements that are necessary to clean, purge and/or ventilate the confined space, requirements for atmospheric testing, requirements for any hot work to be carried out, what materials, including chemicals and tools, can be taken into the confined space, any other control measures that are necessary to control any hazards that are present, requirements for standby personnel and rescue arrangements, and what personal protective equipment is required. The permit will also require signatures for both entry to and exit from the confined space. The permit to work, when properly completed and authorised, usually by the supervisor, is an important document because it identifies the hazards associated with the particular confined space and specifies the steps that are necessary to ensure that they are controlled. So, why do accidents occur? The simple answer is that the confined space permit to work procedure has not been followed properly. In reality, the answer is often a little more complicated. There are 4 common reasons accidents occur. First, inexperience is a major contributor to many accidents. Either not recognizing that a particular task actually involves the entry into a confined space, or not being sufficiently aware of the potential hazards and entering a confined space without taking the necessary precautions. Second, taking shortcuts. Shortcuts are taken for 2 reasons: to save time and simply due to laziness. A few seconds to, for example, clear a blockage is unfortunately often seen as a better alternative than taking the time required to obtain an authorised permit. Third, becoming familiar with a confined space and assuming that the conditions will be the same as they have been before. And finally, responding to an accident that has already occurred inside a confined space. It is a natural reaction to rush to someone's aid if they are in distress or unconscious. This reaction has resulted in many multiple fatalities. All of these reasons for accidents occurring have one thing in common. They result in a hazard or hazards being either completely ignored or not properly controlled. Hazard control is the key to all workplace safety issues. And even though the permit to work in a confined space is designed to identify the hazards associated with that particular situation, there are two groups of hazards that relate to confined spaces that warrant special attention. They are hazardous atmospheres and energy sources. First, let's take a look at hazardous atmospheres. It would not be unfair to say that hazardous atmospheric conditions inside confined spaces cause more fatalities than all the other hazards associated with confined spaces put together. A confined space may contain a hazardous atmosphere, or it may develop a hazardous atmosphere. For example, by a chemical reaction resulting from work being carried out inside the confined space. Or it may be exposed to an external source that will change the initially safe atmosphere to one that is hazardous. For example, fumes generated by a nearby piece of equipment may enter the enclosure. Now, there are four main types of hazardous atmospheres that we should all be aware of, and they are oxygen-deficient atmospheres, oxygen-enriched atmospheres, flammable or explosive atmospheres, and toxic or poisonous atmospheres, all of which are self-explanatory, with the possible exception of oxygen-enriched atmospheres. With an increase in the level of oxygen, objects will burn more easily and more fiercely. The solution to dealing with unsafe atmospheric conditions is not as simple as it may first appear. It is not necessarily a matter of wearing breathing apparatus, although this can be acceptable in certain circumstances. It is very often the case that atmospheric conditions inside a confined space will have a combination of hazardous ingredients. For example, a toxic atmosphere may be combined with a flammable or explosive atmosphere. In this circumstance, it may be safe to breathe inside the confined space with the use of supplied air breathing equipment. But because of the danger of a fire or explosion occurring, entering a confined space with this combination of atmospheric conditions would not be acceptable. In many situations, the only acceptable course of action to take when a hazardous atmosphere exists is to purge the space before entry and to adequately ventilate the space before and during any work. Purging means the introduction of another substance into the confined space that will effectively replace the contaminated atmosphere. Purging is sometimes done with water, but more often with clean air. In the case of flammable or explosive gases, purging is done using an inert or non-flammable gas such as carbon dioxide or nitrogen to force flammable vapors or explosive gases out of the enclosure. The choice of the appropriate purging gas is dependent upon the relative density of the flammable gases that are inside the confined space. The relative density of clean, normal air is set at 1. Sometimes the relative density of the flammable gas inside a confined space will be greater than 1. That is, it will be heavier than air. And in other cases, it will have a density less than 1. That is, it will be lighter than air. If the flammable gas is heavier than air, usually nitrogen is used, and purging should take place through an outlet at the bottom of the confined space. If the flammable gas is lighter than air, carbon dioxide is used, and the flammable gas should be purged through an opening at the top of the confined space. Once purging has been completed, the space must be ventilated with clean air. Ventilation may also be required for other reasons, the two most common being to remove contaminants produced when the work is being carried out, and to reduce the temperature inside the confined space. Ventilation can either be by natural or mechanical means. If the confined space contains enough openings, the natural airflow created may be sufficient to properly ventilate the enclosure. However, more often than not, mechanical ventilation will be required. Mechanical ventilation commonly involves the use of a blower fan and trunking, or an exhaust fan and trunking. Regardless of the method of ventilation, the important consideration is that clean, fresh air is used. Following purging and/or ventilation, the only sure way to establish if the atmosphere inside the enclosure is safe is for an atmospheric test to be carried out. This test must be done by an authorized person, and depending on the particular circumstances, it may be necessary for additional tests to be carried out during the course of the work being performed inside the confined space. Controlling the atmospheric conditions inside confined spaces is crucial if there is any possibility of a hazardous atmosphere existing or developing. The other hazard group we mentioned was energy sources. To be made safe for entry, a confined space must be isolated from all energy sources, or alternatively, energy sources must be controlled to a level where they present no significant risk to the well-being of anyone who is required to enter. There are many energy sources that can be associated with confined spaces, the most common being electrical, mechanical, hydraulic, pneumatic, kinetic, and thermal. Obviously, depending on the confined space, the requirements for isolating the energy sources will vary greatly. Clearly, if there are moving parts inside a confined space and they are inadvertently activated, the consequences could lead to injuries or fatalities. Positive steps must be taken to tag out and lock out all energy sources associated with a confined space before entry. Careful consideration should also be given to any stored energy sources that may be present. For example, it may be necessary to bleed fluid from a hydraulic line or release air or gas from a pneumatic system. Other examples could include flushing out and cooling heated pipes, discharging stored voltage from a capacitor, and securing any items that could fall, roll, swing, or rotate. The exact requirements to control all energy sources for each confined space will be identified in the permit to work. Clearly, as well as the two groups of hazards we have just looked at, there are numerous other potential hazards that could exist. Here are just a few examples. Residual chemicals remaining inside the confined space, uneven or slippery surfaces, lack of visibility, shifting or collapse of bulk materials, excessive noise levels, and extremes in temperature. Confined spaces are dangerous places. Minor hazards in normal work situations can become life-threatening risks in confined spaces. Never become complacent about working in confined spaces. And remember, the only safe approach to working in confined spaces is to diligently follow the instructions that are detailed in the confined space work permit and to always utilize any personal protective equipment that has been identified as necessary. Confined spaces can be safe if approached in the right manner.